is
okay, recorded. Okay.
But how to present? No, not this one. To find my presentation, because you see my screen and not. Okay. I will do this this way.
I started the registration. Gli allumosilicati, buongiorno a tutti. Gli allumosilicati sono silicati cristallini porosi con una struttura cristallografica complessa che dà origine a specifici pori molecolari. Si estraggono da rocce di origine vulcanica, poiché i giacimenti si formano proprio grazie ai depositi di lava sedimentata. Sono usate sia in agricoltura che nell'alimentazione animale perché possiedono importanti proprietà fisiche e chimiche. I colleghi Dejan Prvulovic e Sonja Gvozdenac vi illustreranno oggi i loro studi. Il professore Dejan Prvulovic è professore associato presso il Dipartimento di Cultura e Orticoltura dell'Università di Novi Sad nella Repubblica Serba e Sonja Gvozdenac è ricercatrice associata presso l'Istituto di Campi e Colture Orticole, sempre presso la Repubblica Serba. Desidero avvisare che il seminario sarà registrato e successivamente postato sul sito Facebook dell'Università della Basilicata. Adesso darò il benvenuto ai colleghi in inglese. Alluminosilicati as porous crystalline silicates with a complex crystallographic structure that gives rise to specific molecular pores. They are extracted from rocks of volcanic origin, since the deposits are formed thanks to deposit on the sedimented lava. They are used in agriculture and in animal nutrition as they possess important physical and chemical properties. My colleagues, Dejan Prvulovic and Sonja Gvozdenac, will present their studies to you today. Professor Dejan Prvulovic is an associate professor at the Department of Field and Vegetable Crops, University of Novi Sad, and Sonja Gvozdenac is a research associate at the Institute of Field and Vegetable Crops, the National Institute of the Republic of Serbia. The seminar will be recorded and posted on the Facebook site of the University of Basilicata. Dejan and Sonja, we are welcome and are very happy that you have accepted my invitation.
Thank you very much.
Thank you.
I will start first. I hope that I find a way how to share my presentation. Do you see it now?
Yes, but it's open. Yes, okay.
Okay, I will spread it on the whole screen. Now is everything okay? Because I can't see you, so I hope that you heard me and that you see it. So welcome everybody. My name is, thank you Laura for inviting us to give this presentation, Alluminosilicates in Agriculture. As Laura, Professor Kranos say, my name is Dejan Prvulovic and I'm Associate Professor of Chemistry and Biochemistry at Faculty of Agriculture, University of Novi Sad. And my colleague Sonja Gvozdenac will present her later. I have first part of this presentation, and let's start with it to say something about alluminosilicates and the application of that rock, that minerals in agriculture. First, to say something about what are aluminosilicates. Aluminosilicates are compounds that contain oxides of silicon and aluminium. These compounds are quite common everywhere, and that is not only aluminosilicates that mostly come from that volcanic rocks, but that's not always the same. The clay you meet everywhere, and persons use it from the, I don't know, Neolithic age or so on, prehistoric ages, are also aluminosilicates. Silicon is very specific element, and you know, silicon is very similar to carbon and can make also 4 bonds with neighboring atoms. And someone believes that on some planets, not on planet Earth, that life could be based on silicon as well. On planet Earth, that is, of course, carbon, but because silicon has similar properties, that is, could be possible that organic matter could be made of silicon as well. There also was one episode in, if you know it, File X, that was one TV show a long time ago when I was a student, and there was one creature from outer space that was made of silicon, of course, evil one. And here is one of the classification of silicates and aluminosilicate.
Yes. The presentation. The presentation is not on my screen. You only have the first slide. I'm not sure if everybody else see only the first introduction slide.
Okay, let me see. Do you see now?
Yes, maybe you can share, put the full screen, huh?
It was full screen.
No,
now do you see third one, classification?
What are aluminosilicates? That is the slide now.
Then it's not work well. Okay, can you see
now classification?
Okay, I will leave it this way because it's, I don't know why. You see, I was talking about this slide a few minutes ago. And now here is one of classification of aluminosilicates. If you can see it, now it's a little bit smaller. As you can see, silicates, they're on the internet or in scientific journals. You can find so many different classification of silicates and aluminosilicates, and every of that presentations classifications are different. I choose this one because this one can show you differences between that main classes of silicates. For us, it is important that first tectosilicates, or framework silicates, and phyllosilicates, that's sheet silicates, that is made of layers. Tectosilicates, the most important for this presentation are zeolites, but quartz and feldspars also belong to that group. Silicates or phyllosilicates are mostly, as we know, clays, but not only clays, but some different aluminosilicates as well. They are made of sheets, not of three-dimensional framework. As you can see, that sheet can be made 1-to-1 and 2-to-1, depending how much silicon and aluminosilicates it has. And first, we have something to say about that phyllosilicates, or our special attention will be given to clays. Phyllosilicates are a group of minerals. They are composed of sheets or flat sheets with silicon oxygen tetrahedra, and also with aluminium oxide also in separate sheets. The name comes from Greek word philos, what means leaf. And they are often displayed platy or flaky crystal habit or perfect planar cleavage. As you most silicates are composed of interlocking tetrahedral and octahedral layers combined in the ratio of 1-to-1 or 2-to-1. And it is much easier to see on this picture. As you can see, there is 3 layers of silicon and aluminium. That is one layer, and under it is another layer. Between that layers are molecules of water and exchangeable cations. That is very important for chemical and physical properties of these minerals. Here is another picture with the same structure. You can see 3 layers of different building units, and between that is space that is important for that chemical properties. That interlayers distance depends what kind of phyllosilicates we are talking about are different, and there can be different changeable cations. That is usually cations from the first and second group in periodic system, alkali and earth alkali cations like sodium, potassium, magnesium, calcium, or something like that. Here is some selected phyllosilicates that is most used. They are from different groups, and here's first one is kaolin, or white clay. You maybe heard about kaolin. Kaolin is used to make a china, that special pottery with white glaze and so on. Muscovite is another one that is quite common or used in different industries. Montmorillonite is discovered first in France, and that's why it gets its name. And here is also bentonite or clay, as we know as clay. That clay we use for pottery and use for bricks and everything else. But I have to say the bentonite is not mineral per se, because bentonite or bentonite is mixed of different aluminosilicates, but most of it is in fact Montmorillonite. Over 80 or 90%, depends of deposit, is of bentonite is Montmorillonite in fact. That is the first big group of aluminosilicate that is important for agriculture and agricultural application. Of course, they don't have only application in agriculture, they have application in different kind of industry, chemical industry, building industry, and I don't know, in every kind of industry as well. Second group that is important for us are tectosilicates, and we will mostly talk about zeolites. Zeolites get his name from words zeo and litos, what is in Greek means to boil, and stone or burning stones. Zeolites, why they get that name? Because it has a volcanic origin, and there is a lot of zeolites in Italy, that is, you call it tufo, and as you know, many old buildings are made of this material. That are crystalline materials that contain atoms from alkali and earth alkali group, like, as I mentioned, same as clay, sodium, potassium, magnesium, strontium, calcium, barium. And the basic unit building is that tetrahedral connection of silicon oxide and aluminium oxide that makes it together to make three-dimensional structure. Zeolite has that free spaces and channels in his structure. Here is a microscopic picture of zeolites, and you can see how zeolites are usually sold in the market. Zeolites are quite popular in recent time for so many different applications. Some persons usually sometimes drink it with water for detoxification and use it for different purposes. And how zeolites actually look like? They have that basic building units, that is silicium dioxide and aluminum dioxide. and that make this different kind. This is a basic building unit that can be quite different, and polymerization of that basic building units, we get different structures in the three-dimensional structures. That's why zeolites are quite commonly named molecular sieves, because that is looking like sieves, that you can see different molecules through it. And here is how that pores and channels look like. As you can see, that pores and channels are quite different dimensions and quite a different size, depending on the type of zeolites. There are, I don't know how many, probably 100 different types of zeolites, and they are not all the same. As I forget to mention that zeolites are also recently started to make, there are synthetic zeolites, there are natural zeolites and synthetic zeolites. There is difference between that two groups. Natural zeolites usually has smaller pores and are not so uniform. Synthetic zeolites that are used in industry are usually more uniform, but has much bigger pores and as a natural one. Of course, very popular is to make modified natural zeolites when you can modify, where they modify their structure and with different anions and cations inside. And here are some how structures of that basic and well-known zeolites looks like. Here is analcime. You have that is quite messy structure, and habazite is the second one. Also popular and quite used are mordanite and philipsite, and you can see difference between that two structure. And fifth one, and the most used, is clinoptilolite, and it is used in agriculture quite often, but not only in agriculture, but also in different industries as well. I'm not a geologist or mineralogist, so that's, I know. So if you are interested, you can find there is some groups on internet, international groups, scientific groups. They have quite interesting presentation about these minerals, and they are dealing exclusively with different kinds of zeolites. And there are two factors that determine the possibility of using zeolites in agriculture and industry. There are the presence of inactive sites in the channel system, and the shape and geometry of that pores and that channels, which are responsible for shape selectivity, which in turn that determines the possibilities of performing specific reaction. That active sites in zeolites, or also in clay as well, in all the aluminosilicates, are present inside zeolites, but also on the surface. So zeolites are possible to do absorption and adsorption. Absorption means to make some absorption, to absorb something inside its structure, and adsorption is to bind or to catch something, or surface of that molecule, of that mineral. The presence of micropores imposes steric reaction and diffusion of reagents into the interior of the aluminosilicate channel system, and also prevents the transport and adsorption of macromolecular compounds on active site, and so on. And where that zeolites or aluminosilicates can be applied. Here is this scheme for only for zeolites, but application of clays and zeolites are quite similar. That can be applied in agriculture, in industry, and in household and commercials. In agriculture, that can be applied on plants, that is applied on soil, also to soil to make some soil amendments, also to apply it in animal nutrition, also in plant protection as well. In industrial, that can be industrial application could be as molecular sieves or ion exchange or catalysts or buildings material in how to make combs, or there is so many different application of that materials. But let's start about something, what is the topic of this this presentation, that is application of aluminosilicates in agriculture. And first I will talk something about application of aluminosilicates in animal nutrition. That was my topic for PhD thesis and also for my master thesis as well. On my PhD thesis, I applied some feed additives for chickens. That additives was based on aluminosilicates. That was a mixture of clays and zeolites. And together with that additive, I applied also different toxins in animal feed and check out if that additive can't bind that toxic substances in vitro, in the digestive system of chickens. That was similar for my master thesis, but experimental animals was pigs. And I didn't give any toxin to pig, just check out if that aluminosilicates has some effect on pigs' nutrition, on physiology and biochemistry on the first place. For researchers and for breeders, first question is, does that aluminosilicates, and it is mostly clays, but sometimes also zeolites, improve or reduce weight gain? There are different in literature, there are different results. Some additives improve and some other reduce weight gain of animals. That depends on different factors. At first, on animal species. Chickens has very fast metabolism, and that aluminosilicates stay only a very short time in their guts, and they don't have so much possibility to improve, to show their positive effect in full, because after, I don't know, 1 hour or so, that will go on another side. Pigs has different metabolism than chickens, and there is a much more improved in the weight gain when you feed pigs with aluminosilicates than chickens. Also, different acidity of different parts of gastrointestinal tract could interfere with activity of that applied aluminosilicates. Also, that depends on condition of that animals. Also, it is very important type and level of applied aluminosilicates. If you I show you on previous slides, different aluminosilicates has different abilities, different pores and channels, and some of them can quench that inside digestive system, some substances, while some others don't have that effect. Also, if you applied low amounts, they can't express in full their possibilities. But if you apply too much zeolites or aluminosilicates in feed, you will reduce the nutritional, that valuable nutritional biomolecules from the food, and animals will eat that minerals instead of proteins or carbohydrates or lipids, and that animal will not get as much energy to improve their weight gain. But also, that is what is important to mention, natural zeolites can reduce the incidence and severity of diarrhea in cows and pigs and different animals, and that is very, very important because zeolites generally are very hygroscopic and can quench a lot of water from outside, not only in the digestive system but usually, and that is not that situation is not good for that pathogenic microbes in the digestive system, and that is important. That is the way how zeolites protect animals from diarrhea and from that pathogenic bacteria, or bacteria mostly, and in some cases it's viruses as well. The most studied application of zeolites and clays in animal nutrition is fight against mycotoxins. What are mycotoxins? Mycotoxins are toxic compounds that are naturally produced by certain types of molds, fungi. Have to mention that not all that secondary metabolites of molds are mycotoxins. Mycotoxins, that is one that is produced in special conditions in very low amounts. For example, some molds produce different biological substances that have chemical substances that have biological activity. For example, penicillium is antibiotic, not mycotoxin. Also, that mushroom from the forest are used sometimes toxic, but that toxins they produce is not mycotoxins. So that molds that are present on the grains not always produce mycotoxins. Only in special environmental conditions they will start to produce that different mycotoxins, and that is usually in small amount. The best known mycotoxins are alpha toxins, citrinine, fumonisin, ochratoxin A, patulin, trichotessans, and zearalenone. There are some T2 toxin and some other. We have in Serbia several years ago big problem with aflatoxins. Aflatoxins are usually present in subtropic regions, and we have continental climate. I'm so sorry. Continental climate, but that summer was very hot, and aflatoxin was present so much in the corn, and not only in the corn. Milk was contaminated with quite high concentration of aflatoxins. Generally, that mycotoxins attack liver or kidney or other organs in human and animal bodies. And here is the 4 type of aflatoxins that are usually present in the nature, that is B1, B2, G1, and G2. There is also M1 and M2 that are present in the milk. That is also quite common in the market if you don't check it quite well. And one of the toxins I applied to my chicken when I did performance on my PhD thesis was aflatoxin as well. And how that aflatoxin could be eliminated from the feed. Here is, I don't know how well you see, clays usually has much more ability to absorb that aflatoxins in vivo, and to bind that aflatoxin molecules between that layers I mentioned already that our field silicates are made. And there is researchers started maybe 50 years ago or maybe less to research possibilities to use aluminosilicates in detoxification of aflatoxins from the feeds. They tried also with other mycotoxins, and I also tried with ochratoxin A. Ochratoxin A is quite common in Serbia because it's like continental climate, but there is not so much promises of effectivity of that different aluminosilicates to quench and to bind that other mycotoxin. The aluminosilicates are quite effective against aflatoxin, but other mycotoxins to absorb other mycotoxins not so. Why is that so? Because there is different polarity between that structure of aflatoxins and mycotoxins that containing less polar functional groups. There is no chance that aluminosilicates can't bind them. But that limitation can be overcome by the use of chemical modified clays. And that modification consists of alteration of surface properties to increase hydrophobicity. So change surface and you will have more promising effects. In vitro results have verified the binding efficacy of modified montmorillonite and clinoptilolite against zearalenone and ochratoxin A. That aluminosilicates, zeolites in first, can also bind some herbicides that could be toxic for the persons, for the humans and for animals. In my research, I use paraquat. Paraquat is one quite efficient herbicide, but is not now is forbidden in Serbia and in European Union as well. It is still quite commonly used in Asia, in Far East, and also it's very toxic. It is the most used toxic substances used for suicides in Thailand and in that region of the world, because it's cheap and almost every household has this herbicide, and when persons decide to stop their life, they use that toxin. And during my experiments with chickens, results show up that aluminosilicates are quite effective to quench and to bind that paraquat from the feeds. Also, the dietary use of clinoptilolite appears to be effective in the prevention of organophosphates poisoning. Experiments, as you can see, experiments in sheep have shown that the oral administration of clinoptilolite in the dose of 2 grams per kilogram of body weight is effective against toxicity of organophosphates. Also, zeolites partially protect from poisoning by inhibiting the decrease in cholinesterase activity and by protecting rumen flora in animals, of course, in vivo. Also, it is quite common to use zeolites in the first place against metal poisoning, especially against heavy metals like lead and cadmium. And also, during my experiments, I use lead acetate as a poison for chicken, and I got promising effect because that additive was quite effective. That additive was quite effective against that toxic heavy metal. Also, some other researchers discovered that aluminosilicates are also protective against toxicity induced by cadmium from the feed. Also, high concentration of copper could be toxic to animals, and some researchers proved that addition of 0.5% of phyllosilicates, so in clays, reduce the copper concentration in the liver and protects animal against that toxic metal. It is what is also very important. That is ammonia toxicity. You know that ammonia is a very big problem in Europe because of so great number of farms and so great number of pigs, and there is a big problem with ammonium. High concentration of ammonium in the air, but if you add zeolites or some other aluminosilicates in the feed, and not only in the feed, it can be used to put on the floor of that buildings where on the farms that can absorb ammonium at very high concentrations. And also, that is what is good, that litter or the litter from the animals can be used as a slow release fertilizer for the plants, because that ammonia from the farms can be applied on the field, and as you know, that plant can use that nitrogen from ammonia for their own purposes. How that work? Zeolites release sodium from its pores and absorb ammonium in his channels. Also, it is very not very. Aluminosilicates can absorb some other toxic substances and protects animals. As you can see on this slide, clinoptilolite and mordanite are capable to absorb and partially inactivate some kind of Escherichia coli enterotoxin in vitro and also in vivo as well. There is known that some aluminosilicates can absorb some poisons from different plants and protect the animal after grazing that plants. Also, in my PhD thesis, dissertation, I how to say, experiment with different kinds of toxins, and one of them was microcystins. Microcystins are toxins of cyanobacteria, that is blue-green algae, that could be seen everywhere, especially in the lakes, but under some conditions, they produced that microcystins, and microcystins are hepatotoxins. They attack liver, and that is big problem if that lakes are used for supply of water for big cities. That is something happened in Serbia because we have that lakes that we use that water for supply of, especially in central Serbia, for water supply. And there is not so effective method how to detoxify that waters. And that's why I try to, if we will get any results. And our results were quite promising. I discovered that that mixture of different aluminosilicates can absorb and protect animals from microcystins poisoning. But everything has everything what have positive effects could have also negative effects. Some researchers think that that zeolites, beside that toxic substances, can also absorb some important biomolecules like vitamins, like some acids, and so on. And in that cases, organisms can't get enough of vitamins from the food and feed. Our results did not show that. Our homeostasis of pigs and chickens was not disturbed by application of aluminosilicates in pigs and chickens nutrition feed. Also, some researchers think that application of aluminosilicates in high quantity has slowed down metabolism of animals, and that can lead to higher numbers of pathogenic bacteria in the digestive system. Also, some other researchers think that that aluminosilicates can change acidity of gastrointestinal tract, and that could lead to some other problems in digestion. And that was be the main thing about application of animals of aluminosilicates in animal nutrition. And I will say something about aluminosilicates and plants. As you can see, here is another classification of application of zeolites in agriculture, and how that zeolites can and also zeolites can be applied. When we are talking about application of aluminosilicates in plant production, that's usually zeolites. Why? Because we have clay in almost every soil, and we don't need to apply more clay in the soils. But there is not enough zeolites, so zeolites can change some way that soil and their properties. As you can see here, that zeolites can change soil structure and to has beneficial effects. Also, zeolites can be used as eco-safe pesticides, and Sonja will later say something about that. Zeolites can be used as slow-release fertilizers, as a source of trace element, also can absorb heavy metal absorption, also can be used for wastewater treatment, and so on. And how that zeolites affect soil properties. As you can see, when rain fall down, most of it run off. Depends, of course, of the type of the clay or of the soil. But when we add zeolites inside, zeolites are hygroscopic and can be reservoir of the water in the soil. And also zeolites can prevent as you can see, prevent of leaching of that nutrients onto the underground water. So we can protect underground water by adding zeolites in the surface of the soil, in the surface surface layer of the soil, where is the root system. And here you can see some picture that is from internet I pick up. I don't have my own, where researchers add zeolites and in the soil, and there is quite different in the habitat of the plant and also in the root system. I also have some experiments with application of zeolites in the soil. Zeolites in the soil, we check if that zeolites can absorb lead from toxic heavy metals from the soil, from the contaminated soil. First, the most important thing about application of zeolite in the soil, that is plant nutrition. Zeolites can be used as slow-release fertilizer for nitrogen, phosphorus, potassium, and different microelements. And researchers, what they claim and what they prove, that zeolites improve that free elements uptake and use efficiency in the maize, and also that zeolite can increase the efficiency of nutrient uptake of nitrogen fertilizers in the vegetative grown corn plants in sandy soils, there where is not enough aluminosilicates. Sand is also silicate, but not aluminosilicates. And also, zeolite can be directly enriched with that different micro and macronutrients, and is, as I mentioned, slow release nutrient source for different kind of plant species, because if you applied mineral fertilizers, sooner or later that will finish, great part of it will finish in underground water, and you have to be very careful how much and when you apply it. But when you add zeolites, they will bind it in that surface layer of the soil and prevent it from leaching into the deeper parts. Also, zeolites can be very effective in absorption of toxic substances from the soil and to use for remediation of that soil. Not quite remediation. Zeolites can bind that heavy metals, but that heavy metal still stay in the soil, but is not anymore available for the plants and for the plant root system. And researchers also find out that using zeolites to amend soil irrigated with saline water could mitigate the harmful effects of that high concentration of sodium chloride. Also, as I mentioned, that zeolites can't absorb that heavy metals like cadmium in soybean, and our results show that can absorb lead and protect maize plants from toxic effects of that heavy metals. There is other applications of zeolites, as maybe you will recognize on the picture, is Castello dell'Ovo from Napoli. And that castle is mostly made of tuffo, and that is zeolite, in fact. So that the same bricks and stones used from this castle can be used in animal nutrition or for some other purposes. As I mentioned, zeolites can be used and aluminosilicates for wastewater treatments because it can absorb that toxic substances, and after that you can use that wastewater for irrigation of some other proposes. Also can be used in aquaculture because in intensive fish production, fish produce that high amount of ammonia. That is the way how they release ammonia from their bodies. Fish are specialized in that way. We synthesize urea and release that nitrogen from our bodies in different way. And if you add zeolite in fish ponds, they can bind that surplus of ammonia from the water. Also, zeolite can be used for catalysis and for this different industrial application in chemical industry, and as I mentioned, also for construction material. And you know that clay is used from pottery from the early human civilizations. Also, it is quite commonly used as for odor control in the farms, but not only in the farms. That is added in that that is in the sand for cats and dogs. If you have cats in apartments or dogs in apartment, it is good to have at least small amounts of zeolite that will prevent that odor that they made. So that will be my part. That's all from me. Now it's Sonja's turn, so I hope that you see my presentation, that I was trying to be to understand me.
You have to help me now.
Okay, okay, Sonja, now it's your turn.
You have to help me with I want to present this. Okay. Maybe it will be. Do you see it? Maybe.
Yes.
Yeah, it's okay. It's okay.
Do you see the full? Do you see the full screen now?
Yeah. Okay.
It's okay.
Okay. So first, I would like to thank to Professor Laura for inviting us, and Dejan for also inviting me in her name. Today, I will be talking about natural silicates as biorational pesticides. First, I would like to give one demographic fact. Namely, it is expected that by the year 2050, the human population will reach 9.2 billions of souls, meaning that a 30% higher number of people will be living on this planet, which practically will provide us with a great challenge of providing a sufficient amount of quality and nutritious food for this growing people population. Every time we wanted to provide a bigger amount of food, it meant to intensify agriculture, meaning to increase the use of agrochemicals, fertilizers, and also pesticides. So having this history of increasing pesticide use, frequent use, inadequate use, it caused several negative effects, despite the beneficial role and despite the fact that pesticides are practically inevitable in intensified agriculture. Pesticide use has resulted in environmental pollution, in leaving food residues and threatening human and animal health, and also in developing pest resistance to pesticide, which is nonetheless the problem. So all these negative effects have driven some legislative changes in the last decade, and practically now you have the restricted or even banned use of a number of chemical pesticides that were practically effective against crop pests, and you have need to transfer your pest management to green or biorational methods in a number of European countries, and now it is this trend is spreading to other countries worldwide. These are two main directives upon which the pesticide use is restricted. The second one, issued in 2009, actually deals with the sustainable use of pesticides, and at the same time it promotes the use of alternative alternative means of pest control, including biological pesticides and also physical methods of pest control. And with this group of physical methods, we have the inert dust, which are gaining in importance for pest management. In general, inert dusts represent all dry powders of different origin that are practically chemically unreactive with commodities, with other living organisms, and so on. Inert dusts have been used in the control of pests of field crops and soil products for decades.
Sonja, do you change your slides? We
yes.
see.
You don't
we
see.
see only
Okay.
the
Now.
slides.
Oh, okay.
We don't see slides now.
Do you see it now?
No, we don't see your presentation.
Same problem as with you, yeah? Let me see.
We saw only, don't share it on the full screen.
Okay. Do you see it now?
No.
Use the flash.
Do you see now?
Yes, now.
Yeah.
Yes. But no,
not the full screen.
Not full screen. Not only that way.
Okay, then. So now, okay.
Okay. It's okay.
So, so far, the inert dust in the internet. But they have been used in other fields of pest management. Just in short, Dejan mentioned several classifications of natural zeolites. Here, I would like to make classification of inert dusts that are used for pest management, because from the entomological point of view. We have a group of natural silica dusts. As Dejan mentioned, we have phyllosilicates where Cowling Clays, vermiculite belong. We have tectosilicates with diatomaceous earth, zeolites, sand, volcanic ash, and some others. Then we have a group of minerals and group of dusts with synthetic silica, and also a group of inert dusts that encompass wood ash, rice paddy ash, and all other plant origin ashes. For this presentation, Dejan and I decided to talk about natural silica. And the most important and the most widely used and widely studied are natural silica based on diatomaceous earth, zeolites, and clays. First, diatomaceous earth is dust that is composed of unicellular fossilized skeletons of algae, diatomaceous algae, and they practically contain, since they are skeletons, they practically contain from 80 to 90% of amorphous silicium dioxide, and they can be found, diatomaceous earth is usually dug from the softy chalk rock deposit. It is estimated that the major deposits were formed 30 to 80 million years ago, and in majority of cases, the particles within this dust range from 10 to 50 microns, the majority of them. So based on the number of researches from 50 years ago, and the research on diatomaceous earth has intensified in the last 10 years because of those restrictions on chemical pesticides. So practically the researchers are looking for all possible alternatives. So a number over 200 research papers is published on diatomaceous earth, and also several products are now commercialized and available. We have, for example, silicosec, we have protected, we have dryacid, and so on. And it is commercially used, for example, in the United States at very large scale, in storages, for example. These are all types of different diatoms. And here on the picture down, you have the sample of earth, which is photographed under electronic microscope. Diatomaceous earth has several advantages in comparison to chemical insecticides. It is, as mentioned, inert material, so it doesn't interact with any other, with a commodity or with other surrounding material. It is safe for use, environmentally safe. It is also very effective as an insecticide. It has physical mode of action. It is long-lasting, and it doesn't leave hazardous residues. Another group is a group of zeolites. Zeolites were more described by Dan, so I will be just in brief. It is also categorized in inert dust, like the DE, based on their silica content. It originates from volcanic rocks, and based on the Atlas of Zeolite framework, it is mentioned some 2018 framework of structures and over 50 natural zeolites, and they are all approved by the Commission and Zeolite Association. First, zeolites were discovered back in 1756, and since then, the number of scientific disciplines where they are applied is constantly increasing, from the medicine, veterinary medicine, agriculture, within agriculture, animal production, soil science, and plant protection also. I will not be talking about the structure because Dan elaborated it well. I just want to mention three main traits or characteristics of zeolites, which are responsible for their effectiveness against pests. It is the dimensions of pores, where you have 3 different dimensions, the dimensionality of channels, also 3 different dimensionality, and the content of silica in dust. It is very important, but Dan also mentioned it as well, that zeolites are used for human consumption. So it is practically listed as by the Drug Administration as a non-toxic supplement. And according what is important, according Codex Alimentarius Commission, it is listed as organic food production and plant protection product. So it is practically organic, biorational, eco-friendly plant protection product. What is always the drawback and the restriction with all those natural silicas is practically the reserves. Because you have already in Serbia, you have limited reserves of diatomaceous earth. And we have only at several places where we had mines on the surface basins, we have several localities where we can still dig diatomaceous earth. So the reserves are always a problem. And here you can see that annual world production of, for example, natural zeolite is about 3 million tons. And the major producers are listed here, with, of course, China and Korea. And from European countries, we have Turkey and Slovakia. One of the main reasons for this limited, not limited, but for possible limitation in use is because ever since 1950s, it practically was rediscovered. And from 1950s, zeolites have been used in a variety of different discipline sciences and practical use. So we are practically using and exploiting the maximum amount of zeolite as we can. So there is always a question, how long will they last us? But then Dan also mentioned the scientists have found a way to create the artificial or non-natural silica. So we'll see what happens. And we have also Cowling Clay, which is mentioned in a lower number of studies, but I will present you one result from our study later on. And from my opinion, Cowling Clay also has a good insecticidal perspectives. Here are all the agriculture fields of where the natural silica dust are being used. They showed good efficacy in communal hygiene against some mosquitoes, bed bugs, ants, mites, and so on. And in agriculture, they have been tested in fields against melligators, melolonta, moths, potato beetle, and so Colorado potato beetle, and so on, with strong effect. However, in field, there is always a problem of application, because you see on the left here, they use like a spoon or whatever to toss it over the plants. In the storages, it is a bit different story, and the silica dust are the most studied. Their use is most well studied in storages, and they have been proven to be very effective against Cytophilus species, rice, grain, and maize weevil, against Rhizoperta dominica, against flower beetles, Tribolium species, against tobacco bug, Lasioderma, and also another Tribolium species. I did not put all the species here because it would take me a larger list. We did some research on Plodia interpunctella, also Indian meal moth and Ephestia kiniella, and the results were also the efficacy was very satisfying. Here are one example from our work. Dan and I published this work. You can see the Diatomaceous Earth effect on Cytophilus oryzae. Practically 100% efficacy was achieved at the highest rate after 24 hours. The same was with Cowling Clay. Practically even at lower concentrations, it reached the efficacy of 100% after 7 days. And here is the comparison of Diatomaceous Earth, kaolin, and vermiculite. Vermiculite is also one phyllosilicate, but it's not so far hasn't been so well exploited in plant protection, and we wanted to try if it can also work. And as you can see, its efficacy was not so satisfying, but the problem was probably because it was the larger particles were applied. So kaolin was even more effective at higher rates compared to Diatomaceous Earth. Even at lower rates, it was more effective than Diatomaceous Earth, but it is a bit underestimated maybe, or underused so far. Here I wanted to tell something about I have to move this because this was planned to jump in the slide. Maybe I can do this. Do you see the entire slide?
Yes, we see.
Yes.
Okay. So basic mode of action of natural silica was described back in 1931, and it was called Zacher effect. It was named by the scientist who discovered, Zacher and Kunicki, who discovered that in inert dust, this was related to zeolites at that moment, that zeolite caused dehydration and desiccation of insects. First, I have to make one digression, and to remind, if somebody doesn't know, insect's body is covered with exoskeleton. Exoskeleton is a firm layer made of cuticular lipids who practically prevent body loss from insect's body. And what do inert dust do? They absolutely do the opposite. They practically cause the abrasion of insect exoskeleton cuticule and enable water loss, leading to desiccation. Additionally, they bind the water from the cuticule because, as Dan mentioned, they have big absorptive power. And additionally, they absorb the lipids itself. So the exoskeleton and epicuticula, they practically become very porous and permeable, and the water practically loses from insect's body. Another mode of action is the spherical blocking and asphyxiation due to fine particles that practically stuck on insect's body. And another mode is ingestion, because they enter the mouth through mouth parts. They enter insect's mouth and their digestive system, and practically they cause the ingestion. Here are some pictures, different rates applied to wheat grain, different rates of diatomaceous earth, and you can see the insect body completely covered, slightly covered, or uncovered with the diatomaceous earth. Here is one nice picture. I have to put it on a big screen. Do you see the big picture, microscopic picture of insect?
Yes.
Okay. You can see the fine abrasions caused by diatomaceous earth particles, and as they are stuck, they're also stuck on the insect cuticule. Okay, I will get to the next slide. So, as mentioned, all those inert dust based on natural silica have big advantages, but every advantage has also some disadvantages. I would say with natural silicas, the requirements are the greatest disadvantages. Why? Because the efficacy of inert dust is strongly depending on environmental conditions, on insect species, and on the structure of dust. When I say environmental conditions, I primarily mean the humidity of the air and substrate. The best efficacy is achieved when the substrate is dry and the air humidity is very low. Also, the higher the temperature, the bigger efficacy. The grain temperature and the field atmospheric temperature is also important, as well as the condition of a stored product, if we speak about the protection of a grain stored product pests. Because when you have cracked grain, or you have better efficacy than you have a whole grain, because it is better absorbed. As for the species, soft-bodied species, and with the softer wax layers are more prone to the inert dust. And also the structure of a dust is very important and more, I can say, crucial for its efficacy, because it depends on the content of silicium and also the content of other, for example, metals, aluminium or other metals that are contained. Also, it depends on the shape and the size of particles. Finer particles, when they are a majority in the dust, the efficacy is better because the abrasions are numerous and smaller. So in general, we can conclude that inert dust based on natural silica will control insects as long as it is dry and as long as it is applied at sufficient concentration. Here are three ways of application of inert dust in storages. One is admixture with grain, other is as structural treatment on walls and floors, and you can add it on a bulk, grain bulks, just toss it over the surface. However, the mixture with grain is usually avoided for the several reasons, because the inert dust reduce the bulk density, they affect the flow characteristics of bulk grain, and also they leave visible dust residues, and which can also cause health concerns for the people who are working with them. So, in general, it is recommended that IDs are used for surface treatment as preventive measure, not as a curative measure. I have to mention that natural silicas are well positioned in terms of toxicity and human and animal health because of low mammalian toxicity. So I'm not talking about zeolites. They were also mentioned as a medical purposes. They're also environmental friendly. They do not pose a hazard to wider public, and they do not cause human cancerogenity. I mentioned also this Codex Alimentarius, but it was mentioned in the previous slide, so I don't want to repeat myself. Even if they've been studied for decades and with good efficacy, with good results, there are some obstacles to wider commercialization. Diatomaceous Earth has already some products for plant protection registered. However, I can see that the producers, that the manufacturers of other inert dust are having second thoughts about if they're going to register the product or not. Why? Well, because it is dependent on, as I mentioned, environmental factors. So they do not want to be responsible for its low efficacy if the producers do not follow the recommendations of the right application. Also, the efficacy of different dusts can vary between the same insect species. So you have to be very thoughtful which dust will you choose depending on an insect species. Also, the efficacy can vary even between different species with the same ID. As I mentioned, it affects grain flowability, so practical use in big storages is questionable. The dust appears on treated grain, so some might say we don't like it, it has some residues. Never mind, because it's not harmful. And also for safety reasons, because sometimes when you apply the dust on a bulk or as a surface treatment, it does leave particles in the air for 2 or 3 hours, because until they fall down, because it is a fine dust. And unless it is used with all measures with a gas mask, with the glasses and all, it can cause some irritation of based on inhalation. So some obstacles are here, but I can see that they are tended to be overcome, because we really need some green pesticides, some physical methods, and really need alternatives to chemical pesticides and insecticides so far used, especially in storages, because the number of active ingredients enabled for use in storages has reduced to probably 1 or 2. And this is all from my part. I would like to thank you for your attention, and also to thank Laura for giving me this opportunity.
Many thanks. many thanks.
Any questions?
Very
Any
interesting.
questions?
Tell me.
I said, if you have any questions, I'm here for.
Yeah. Very interesting presentation. You have covered the subject in the whole aspect. Have question, people? Have you a question? Speechless.
When I was talking with Sonja yesterday,
Yeah.
I wanted to say that if you have any question for Sonja or for Sonja, just ask her.
Yeah, no, for all people know that we are very very interesting presentation. Very interesting presentation. Thank you so much. Avete domande? Avete domande, ragazzi? Potete farle in italiano, li traduciamo? No, question.
No.
Ok, va bene. Giuliana?
Sorry, I was late because I had lesson, but in this last time, really very interesting the results that you presented in this seminary. So only congratulations for this very interesting meeting. Grazie, Laura.
Thank you. Thank you
very much.
Okay, then we can finish, and I send to you the video. When I arrive with Meet, the video, the registration, I send to you. Then you can publish in your site if you want. Okay.
Thank you.
Okay.
Thank you. Hope to see you soon. Next opportunity.
Yeah.
Yes.
I hope that in the future to meet personally.
Personally, definitely. Yes.
I still did not get any information from my international relation office about our bilateral that.
Yeah.
Does our rector sign it or not? I suppose that they forget about it, and that I will have to press them a little bit.
Okay, you can remember your rector, please, because it is necessary to put in the database this.
Yes, I will do it this day. Yes.
Ok. Beh, buona giornata a tutti. Have a good day.
Bye bye.
Bye bye.
Bye bye.
Bye bye.